Hi, this is Kevin from Mathsaurus, and in this video we're going to be working through questions 21 to 25 of the Senior Maths Challenge from 2020. I've put all of these questions and more in a free online course, Get Ready for the Senior Maths Challenge. In that course you can work through all of these questions, not just with the video solutions, but also with my video hints before each questions to help you get into the question and to solve it yourself. So I think that's really the best way to prepare for the Senior Maths Challenge. I'll put a link in the description below. You can go over there and sign up. It's totally free and there's no ads or distractions like there are here on YouTube. So do go and sign up over there. Of course, if you'd rather watch the solutions right here on YouTube, you're very welcome to as well, and we will now get on with solving those problems. Right, this is quite a nice question. Pay attention to the form questions are given to you in. There's often a clue in the way things are written down. Here it says we've got 10 to the 2020 plus 2020 all squared. Again, the maths challenge getting the current year 2020 in a lot in this paper. But this should really remind you of just the form x plus y squared, and we know that x plus y squared is x squared plus y squared plus 2xy. So I think my first thought here is to write this as 10 to the 2020 plus 2020 squared, to take x equals 10 to the 2020 and y equals 2020, and then I'm going to get 10 to the 2020 squared, which by the rules of indices is just 10 to the 40, and then I've got to do 2020 squared and then 2 times 10 to the 2020 times 2020. Okay, so actually each of these things are reasonably easy to deal with, right? 10 to the 40 is just going to be a 1 with a lot of zeros after it, right? 40 zeros, I guess. And this gives us this 41 digit number overall. 2020 squared, well, we can just work that out. I suppose I could do, let's do 202 squared, I suppose. So 200 times 202 would give me 40400, and then I'd need to add on another 2 lots of 202, so that would be another 404, so I'd get 40804, or you could just do it as an ordinary multiplication if you want to, and of course that was 202 squared, so 2020 squared would have another 2 zeros on the end, and then 2 times 10 to the 2020 times 2020 would be 4040, and then loads of zeros on the end, like 2000 zeros, 2020 zeros, right? So now the final answer we've got here is just these things, added together, these three numbers added together. But this one's got like over 4,000 zeros in it, so I'm going to start with the 1, and then after like a couple of thousand zeros, finally, this number will appear here, so I'll get 4040 whatever, and then this number here won't appear until the end, so I'll add that on and I'll get 4080400. So I can actually write down this whole number quite easily, as long as I don't actually want to write out all the zeros. Because those bits don't overlap, I can say, well, what's the sum of the digits? Well, I just add these together. I get 1 plus 4 plus 4 plus 4 plus 8 plus 4. That's 12, 16, 24, 25. And then the answer is C, 25. So we've got a square with perimeter 4 centimeters. That means that the side length of the square is going to be 1. And it can be cut into 2 congruent right angle triangles and 2 congruent trapezia as shown in this diagram. So the 4 pieces can be rearranged to make this rectangle. And we want to know what the perimeter is in centimeters of this rectangle. So we've got to work out what the lengths are in this picture, I think. Now, the key thing that matches up here is this side here, right? So that means that the shorter side of the triangle here and the shorter side of the trapezium are going to be the same length. So let's just call that x, and then that x as well. They must be equal, and then from that we can work out all of the other lengths, right? This is 1 minus x, so that means that this is x and 1 minus x as well. This bit here must be 1 minus x and 1 minus x and x, so I've got every part of that labelled. So I can also go through the rectangle and do the same thing. Well, this must be 1 minus x, this must be 1 minus x, this is 1, this is 1 minus x, this is 1, and this is 1 minus x. So the perimeter in terms of x is just going to be all of these added together. So I've got 4 lots of 1 minus x and then 2 1s, so that gives me 6 minus 4x. So if I can work out what x is, we can certainly work out the perimeter. So there's a couple of ways you can do it. I think matching up the areas of these two shapes is one way that makes sense. I think when I looked at this, I thought about similar triangles. So so let me just say, you could just do this by saying area of square equals area of rectangle, and that will give you an equation. But I looked at this triangle. I think so I've thought about similar triangles too much probably in my life, but what you've got here is 1 and 1 minus x and 1 minus x here, and then this would be x. So by similar triangles, I could say that x over 1 here is equal to 1 minus x over 2 minus x, right? Because this length is 2 minus x. So I'm saying I've got two similar triangles. The small one here, which has got sides x and 1, and the equivalent sides on the similar larger triangle are 1 minus x and 2 minus x, like that. So we can just turn this into an equation. Well, it is an equation. We can multiply by 2 minus x and get 2x minus x squared equals 1 minus x. So I've got 0 equals x squared and minus 3x plus 1 here, and we can certainly solve this however you want to find x. Let's just use the formula. X equals 3 plus or minus the square root of 9 minus 4 divided by 2. So that's 3 plus or minus the square root of 5 over 2. Now, if you think about it here, 3 plus root 5 over 2 is going to be way too big to be sensible in this question. So actually we're going to just take 3 minus root 5 over 2 to be x. And then we've just got that the perimeter that we're looking for is 6 minus 4x. So that's 6 minus 4 lots of 3 minus root 5 over 2. And this works out quite nicely because 4 times 3 over 2 is 6. And I've got minus root 5 over 2, so that's plus 2 root 5. The 6's cancel, and we get the final answer that the perimeter is 2 root 5. A function f satisfies y cubed times f of x is equal to x cubed times f of y, and we know that f of 3 is not equal to 0. And so we want to work out what the value of f of 20 minus f of 2 divided by f of 3 here is. Obviously, if f of 3 was 0, this wouldn't really make sense. So it might be a bit hard to work out where to start here, but really I think the only numbers we've got here that could be sensible for x and y that would be useful will be 22 and 3. So we might just start playing around with those. So if you substitute in different combinations, you'll find that the thing that's useful here is to, if you make one of them 3, so let's say make f of y, so let's make this f of y f of 3, so let's make y equals 3. And then let's make x equals 2, right? So x equals 2 and y is 3. Putting that in here gives me y cubed, which is 27, times f of 2 is equal to 2 cubed, which is 8, times f of 3. And the nice thing about this, you see, is that it allows me to write f of 2 is equal to 8 27ths times f of 3. And now when you think about this, this is going to be helpful. Because if I also do x equals 20 and y equals 3, that would tell me that 27 times f of 20 is 20 cubed, which is 8,000 times f of 3, and that would give me that f of 20 is equal to 8,000 over 27 times f of 3. So when I'm looking at this f of 20 minus f of 2 over f of 3, what I've got is 8,000 over 27 times f of 3 minus 8 27ths times f of 3 divided by f of 3. So we can factorize an f of 3 in the top if you like here and say, well, this is just f of 3 times 8,000 over 27 minus 8 over 27 divided by f of 3, or you can just cancel it right away if you can see that, and they cancel out. So I've got 8,000 27ths minus 8 27ths, so 8,000 minus 8 is 7,992 divided by 27. So we could do the division by 27 directly here if you want to, or we could do something like dividing it by 3 times, or dividing it by 9 and then by 3. Let's divide it by 9 and then by 3. I think that's going to be reasonably quick. So 9 times 8 is 72. We've got 7 left over. 9 times 8 is 72 again with 7 left over, and then 9 times 8 is 72. So I've got 888, and then I just need to divide that by 3. So I've got 2 with 2 left over, and then I've got 9 with 1 left over, and that gives me 296. And so the answer must be D, 296. So for this question, I've just made a bigger copy of the diagram here, and we will just go through the question and annotate it slightly. So in the diagram, M is the midpoint of PQ, okay? The line PS bisects RPQ, so the angle RPQ, so actually I'm just going to label this one X, and then this one will be X as well, and that's bisecting it. So the line ST is parallel to PR, so this one and this one are parallel, and intersects PQ at T, okay? The length PQ is 12, so that's that whole length across here, and the length of MT is 1, okay? So the angle SQT is 120 as shown. What's the length of the angle? What's the length of SQ? That's what we want to work out here, this part here. Okay, so you need to look at this quite carefully. You probably have to look at it for a while. And really with this question, just write in anything you can. Something that occurs to me fairly early on in this question is that we have to use the parallel lines somehow. And when I've got parallel lines, sometimes it can help just to extend them to sort of see the cases of the theorem. I think the official solutions here go a little bit around the houses to work this out, this first step, but actually this angle here is just alternate to this angle here. So we've got alternate angles, this one is equal to X as well, and that means that this triangle PTS is isosceles. Now we've got the information about the lengths here, so P to M would be 6 and M to T is 1, so that length is 7, and that means that because this is an isosceles triangle, PTS, that this length here would be 7 as well. And of course we know that the length TQ would be 5, because the total here is 12. Now if we just look at this triangle here, let's just draw it again so it's a little clearer. We've got STQ, so that length is 7, this is 120, and this is 5, and we want to work out y here as the answer to the question. So we're just going to apply the cosine rule to this. So let's just get that out of the way a little bit. And so the cosine rule say a squared equals b squared plus c squared minus 2bc cos a. And I'm going to have to take this as the angle A then. This is A, and then either of these is B and C. So I've got a squared is 49. That's going to be y squared plus 25 minus 2 times 5y, so that's minus 10y times cos of 120. Now for the Senior Maths Challenge, we should be able to work out things like cos of 120. This is a topic that I cover in the course Get Ready for A-Level Maths. The teaching videos in that course are available for free, and so there's some videos talking about working these things out in there, so I'm going to assume that you kind of have seen this sort of thing before. There are different ways of doing this, but I'll do it with just a quick sketch of the cosine graph. This would be like y equals cos x or something, so it goes through 90 here. So if this is 60 and 120, they're kind of symmetrically opposite each other. So all I'm trying to work out in my head here is just to remember that I know that cos of 120 is minus cos of 60, and cos of 60 hopefully you know is a half, and if you don't, you could also work that out quickly by doing something like drawing an equilateral triangle. Sometimes in maths it's just as good to remember how to derive things as it is to actually memorize tons of things. So if you take an equilateral triangle with side length 2, then the angle here would be 60, and we can see from this right angle triangle that cos of 60 is the adjacent over the hypotenuse, which is a half. So anyway, I got cos of 120 is minus a half, so this becomes 49 equals y squared plus 25, and then I've got plus 5y when I replace that with minus 1/2. So we've got y squared plus 5y minus 24 is equal to 0 then. We can factorize that as y plus 8 times y minus 3 is 0. So this length we're looking for is either minus 8 or 3. The length can't be negative, so it must be the case that the length SQ that we're looking for is 3, and the answer is B. So question 25 is always going to be a tough one. This is no exception. And we've got a regular m-gon, a regular n-gon, and a regular p-gon. They share a vertex, and pairwise they share edges, as is shown in the diagram here. I want to know what's the biggest possible value of p here, i.e. what's the largest number of sides that one of these polygons could have. Now, one thing I always think is it's easier to work with exterior angles than interior angles just because the formula is simpler. And so something that occurred to me here is that if we just extend this line out here, I've just written this diagram without the words on it, then this would be the exterior angle for the m-gon, right? Just those two would add together to give 180. This would be the exterior angle for the n-gon, and this would be the exterior angle for the p-gon. And we can see that the exterior angles have to add up to 180 degrees. We get a straight line there. Okay, so that's what I'm going to use here to solve this problem. So the exterior angles are just 360 over m, and we're going to have 360 over n and 360 over p. They have to add together to give 180. And if we divide this all by 360, we just get that 1 over m plus 1 over n plus 1 over p is equal to 1/2. So we've reduced the problem to just solving this equation, but I need whole number integer solutions for m, n, and p, and I'm going to do this now in a very maths challenge sort of way. So this wouldn't be like a full rigorous mathematical proof if I didn't have the answers in front of me, but we know the answer has to be one of these 5. So let's just go through and see if any of them are possible. So let's see if we can do it with p equals 6, right? So I would need 1 over m plus 1 over n plus 1/6 is 1/2. And okay, so 1/2 minus 1/6, that gives me 2/6. So I'd need these two add together to give 2/6, and then we can see, we can easily do this by just taking m and n to both be 6. So I'd get 1/6 plus 1/6 plus 1/6 is equal to 1/2. So I could just have 3 hexagons all meeting together. So A is certainly a possibility here. Okay, let's try and do it with B. So you might not start with the smallest ones, by the way. I mean, I'm going to do this reasonably thoroughly here. So if I tried to take p equals 20, I would need 1 over m plus 1 over n plus 1/20 equals 1/2. Okay, so I'd need 1 over m plus 1 over n is 1/2 minus 1/20. Okay, so that's 10/20 minus 1/20, that's 9/20, and you can see fairly easily here that if you do 1/4 plus 1/5, you get exactly 9/20 here. So B is certainly possible as well. If we try it with C, well, I'd want 1 over m plus 1 over n is equal to 1/2 minus 1 over 42 this time. So that would be 21 over 42 minus 1 over 42, so that would give me 20 over 42, which is 10 over 21. And again, we can see here fairly easily, you've got 7 times 3 is 21 and 7 plus 3 is 10. So 1 over 7 plus 1 over 3 gives us 10 over 21. So I could take m, n, and p to be 3, 7, and 42, and C then works. So certainly we've ruled out the answer to the question being A or B. Now if I try p equals 50, now this time I need 1 over m plus 1 over n is equal to 1/2 minus 1/50. So that's 25/50 minus 1/50, that's 24/50, which is 12 over 25. Now this time we can see that if this is going to work, 1 over m plus 1 over n, to give the simplified fraction having a denominator of 25, basically either m or n is going to have to be a multiple of 25 here. I can't just do like a fifths plus a fifth, that would just give me something in fifths. Now if p is 50, that means the only options would be doing like 1/25 plus something, and or 1/50 plus something. And I'll just leave you to check here that when you do 12/25 minus 1/25 would leave me with 11/25, that's not 1 over something, and 12/25 minus 1/50, that would give you 23/50, that's not 1 over something either. So there aren't going to be any fractions here with whole numbers that make this work. Okay, I'm doing this in a bit of a sort of hacky maths challenge way, but we can see here that D is not possible. And we can also see the same for 100. If you do 1 over m plus 1 over n plus 1 over 100 equals 1/2, so I would need 1 over m plus 1 over n is 1/2 minus 1/100. That would be 49/100. In the same way, I need a factor of 25 in one of these fractions, so it's either got to be 1/25, 1/50, 1/75, or 1/100. for one of these, and I'll just leave you to check that when you do 49 hundredths minus each of these fractions, you don't get something you can write in the form 1 over n, and so we can just see that those cases are all impossible. You might be able to do that last bit in a bit more of an efficient way, and if we thought about this a bit more, we could perhaps come up with a proof that didn't require just using the answers here. But the point of this course here is to help you get ready for the maths challenge, and I wanted to show you how I would do this question if I was thinking about it in a maths challenge way. I'm really, in the maths challenges, trying to get some nice mathematical answers, but I'm just also trying to use the time I've got available as efficiently as possible. So if using the answers can help us get there more quickly, we should definitely do that. And then after the challenge, perhaps we can go away and think about why it's true in some deeper sense. So really well done if you got to that answer, however you got to it, and that brings us to the end of the 2020 Senior Maths Challenge paper. Really hope you found that useful. Don't forget that all of these questions and more are included in the free online course Get Ready for the Senior Maths Challenge, where you can work through all of these problems and more with the video solutions and also my video hints. You can select the answers, it'll tell you which ones you've got right or wrong, and you can work through the whole paper like that. I really think it's the best way to prepare for the Senior Maths Challenge. Anyway, really hope you found this useful. Please do like the video and subscribe to the channel if you haven't already. It really helps me get this content out there and helps get this into the feeds of as many people who might find it useful as possible. Anyway, that's all for now. I'll see you in the next video.